In order to take the next step in geometry, we need to take what we already know and expand on it. We understand points. A point in a space can exist on a plane. If I take two of those points, I can connect them with a line. If I take that line, I can find interactions between it and another line. For example, if I take one line and draw another line directly next to it, we can have parallel lines. These are lines that are on the same plane but do not intersect. You can think of parallel lines as train tracks. A train track that crosses the rails would not be very effective. So you could extend these three lines in either direction infinitely and they would never cross. However, if I take that line and I have it cross the other, it creates an angle. So an angle is formed when two lines cross. Now a line that has an end to it, so one end stops and one end continues forever, is considered a ray. So an angle really is two rays that have the same end point. The rays are the sides of the angle, and the end point is referred to as the vertex. In this case, our vertex is that middle point where the two lines overlap. We make 4 total angles in this case. A very specific interaction between these two lines, if I keep spinning that blue line, I can make a 90-degree angle. Because I can rotate that blue line 360 degrees, if I break those 360 degrees up into 4 sections, I get 90 degrees. 360 divided by 4 gives me 90. When I have two lines that make a 90-degree angle, so they make a plus sign, we're going to call those lines perpendicular. They cross at a 90-degree angle. Let's talk a little bit more about parallel lines. Parallel lines never cross. That's the easiest definition. That's the easiest way to observe two parallel lines. So line A and line B do not cross. They are parallel. They're like train tracks. Parallel lines have the same slope but different y-intercept. It's logical that they'd have the same slope because they both rise and run at the same rate. They both move up and over to the right in this case at the same exact rate. So if line A's equation was y equals 2x plus 3, then line B would have the exact same slope. Y equals 2x minus 2, for example. If they have the exact same slope, we know that they are parallel lines. We can also mark on the lines that they're parallel by putting an arrow on each line. This little arrow signifies that line A and line B are parallel to one another. We can write this in shorthand as well. We can say that line A is parallel to line B. That symbol, which looks kind of like an equal sign standing straight up, represents parallel. Perpendicular lines cross at a 90-degree angle. It's a very specific angle. So line C is perpendicular to line A and line B. Because A and B are parallel, if it's perpendicular to one, it's perpendicular to the other. Perpendicular lines have inverse and opposite slopes. So inverse means the reciprocal, it's flipped. Opposite means opposite sign. If the slope's positive, its perpendicular slope is negative. If a line's negative, its perpendicular slope is positive. So if we know that those two lines, y equals 2x plus 3 and y equals 2x minus 2, are parallel, it makes sense they have the same exact slope. So my slope for those two is 2 over 1. If I take the inverse of that, I get 1 over 2. 2 over 1, reciprocal, is 1 over 2. It was positive 2, so that my slope is negative 1/2. The only difference is the y-intercept's going to change. When we draw perpendicular lines, we like to symbolize that there's a 90-degree angle by putting a little square on the angle. This symbol represents a 90-degree or right angle. So I would draw it right where they interact, right where they cross. A little square to say this is a 90-degree angle. When we write it out by hand, we could say that A is perpendicular to C. Line B is also perpendicular to C. If you notice, the perpendicular symbol looks a lot like two perpendicular lines. Two lines making a 90-degree angle with one another. Angles are more complex, but it's still the same concept that we have lines and rays interacting. So here's a line. It goes forever in both directions, line AB. Here's ray CD, because it comes to a point, it comes to a stop. And here's line FE, keeps going in both directions. Angles range between 0 degrees and 360 degrees. One full turn around is 360 degrees. If I spun ray DC like the hand of a clock, it would cover 360 degrees all the way around. When we refer to angles, we usually refer to the points that make up the lines and rays that compose the angle. So let's name some angles. If I have this angle right here, I look at the points that are making it up. I see DCA or ACD. Either way, we would call it angle ACD. Both would be correct, DCA or ACD. Use the three angles. So if I refer to it, all I have to do is find those points. For this angle, I see D, C, and B. F is in there, but it does not contribute to the total angle we're looking at. It actually breaks up that angle. So we're going to ignore the F. So this is angle BCD or angle DCB. As long as you have the 3 points and you're writing them in order. The middle point in both cases, in this case C, is the vertex. Every time it's the point where the vertex or the meeting point of those two rays is. We measure angles with a tool called a protractor. We measure using a protractor following a couple steps. Line up the center with the vertex of the angle. Line the 0 mark with one of the sides of the angle. Then read the measure that lines up with the other side of the angle. Every angle has 2 sides and 1 vertex. So I start by lining up the center of my protractor with the vertex. Protractors have little circular parts. I'm going to line that up over my vertex. Next, I'm going to line up the 0 mark. Notice there's that little red arrow. So I took my one side, my red side, ray DC or ray CD, and I lined up the 0 mark of my protractor with that line. Now if I look, the other half of my line, so I'm trying to measure angle BCD, the last one we looked at, the other ray lines up with 140 degrees. So this is a measure of about 140 degrees, maybe a little bit more than 140 degrees. Let's try another angle. We're going to measure ACD, so the 2 angles that we looked at earlier. Vertex and the center of that protractor line up, so that green point C is where I'm lining up the vertex. I'm going to line one side, in this case the blue side, which is AC. I'm going to line that up with the 0 on my protractor, and I'm going to see where it reads. It reads at about 40, maybe a little under 40. So you line up the 0 mark with one of the sides and you read the other side. You just want to make sure that the center of the protractor lines up with the vertex of your angle that you're measuring. Angles fall into a couple of categories. Acute angles are smaller than 90 degrees. So angle ACD is smaller than 90 degrees. It's acute. You can think of something that is cute is usually something that's small, little, smaller than 90. We can prove that by measuring angle ACD. Line up the center with the vertex, line one side up with the 0 marker, and measure the other side. This is a little under 40 degrees. We also have obtuse angle. If an acute angle is smaller than 90, an obtuse angle is larger than 90. this case, we can look at angle DCB. I can measure that to double check. I line up the center of the protractor with the vertex of my angle, line up one side with the 0 marker, and I read from the other side. It's at about 140 degrees. 140 is bigger than 90 degrees. We also have another very specific angle, and we talked about this earlier. This is a right angle. This is exactly 90 degrees. This is the angle created by two perpendicular lines. So angle ACE is an example of a 90-degree right angle. I can prove that by lining up my vertex, lining up one side with 0, and counting around until the other side I can see is at 90. Sometimes they're referred to as straight angles, but a line has 180 degrees. If I measure angle ACB, I would just see that it goes from 0 all the way over to 180. Complementary angles add up to 180. So angle ACD and angle DCB added together make a straight line, or 180 degrees. Supplementary angles add up to 90 degrees. So I have angle ACD and angle DCF. If I add those two together, I see that they make one 90-degree angle, one right angle.